Continuing with this A-level paper from June 2019, and it is Edexcel. So we're looking at this function, which is 2x plus 4x. So fx equals 2x squared plus 4x plus 9, and they want us to complete the square so that we put it in this form, which will show us where the turning point is. So we're going to have to take 2 out of the whole thing and divide through by 2 for this bit. So x squared plus 2x. And then leave the 9 out. That way we do less work at the end. And then we can now make it 2. And then it's x. And you halve the coefficient of x, so it's plus 1 squared. Unfortunately, then we're going to have a minus 1 to deal with, because that's what we got from that. So we say minus 1, then plus 9, and then that leaves us with 2, x plus 1 squared, and then that's minus 2, because we're timesing it out by 2. So minus 2 plus 9, so that equals 2x plus 1 squared plus 7. So that means that A equals 2, B equals 1, and C equals 7. I'll do it in a slightly Germanic way. Now sketch the curve. So that means our turning point is minus 1, 7. Now, sketch the curve of this showing any points of intersection with the coordinate axes and coordinates of any turning point. So, if we do a little graph here, we know it goes through 9, and we know the turning point is minus 1, 7, which is, so that's not actually that far off there. So it would be about there. So minus 1, 7. And then we just draw this in. So it means it doesn't actually have any real roots because it doesn't actually touch the x-axis. So that is 1, by the way. 1, 7. It's not beautiful, but it'll do. Right, describe fully the transformation that seems a lot of marks for that, now that I've done it. Right, so that's B. Describe fully the transformation that maps the curve with the equation fx onto gx, where gx is this. So gx equals 2x minus 2 squared plus 4x minus 3. Okay, we are going to put this bit here into wherever x is in the f function. And we will get, so f, let's do it, so it means 2, and then we put x minus 2 squared plus 4 x minus 2, that's no longer squared, plus 9. And that's what we are now going to work on, because that's our transformation. There might be one more thing we have to do. So that means we get 2 x minus 2 plus 4x minus 8 plus 9, which is 2x minus 2 squared plus 4x plus 1. Now the problem is that the only difference between this and this, so if we look, this is the same as this is the same as this, but this is 4 greater than that. So in order to make this work, we have to add 4 to the gx. We have to take 4 away. No, we have to add 4. No, I think we have to take 4 away from this, and then that will make that work. Hang on. No, we're taking 4 away from that. Yeah, of course we're taking 4 away from that. We're making that one look like, we're making fx look like gx. So take away 4. So in order to tell the graph what to do in order to become this, we have to tell it, so the x has to go up to, so x is going up to, and the y is going down 4, because that's outside the brackets, so that happens there. Therefore, the overall translation, there we go, equals 2 minus 4, and that's that. Now, the last thing we're asked to do on this is to find the range of the function. So we know that if we put in minus 1, which is the turning point, which is the lowest point, we will get 7. So we know that 21 over 7 equals 3. And otherwise, if we put in 0, we'd get 9. So therefore, our turning point, or rather, our range is going to consist of, so fx range equals 0, x, 3. And that's us done.